So our today's topic of discussion is Boolean algebra. So we all know algebra in mathematics, but we have a very interesting topic, Boolean algebra. So Boolean algebra is basically developed in 1854 by George Boole, and in this book, an investigation of the laws of thought means he investigated laws of thought and is a variant of ordinary algebra. So this is basically Boolean algebra is a variant of ordinary algebra as taught in high school. Boolean algebra differs from ordinary algebra in three ways. So how it differs from ordinary algebra? So basically in three ways it differs. So let's see what are those three ways. In the values that variable may assume, which are of a logical instead of numeric character. So when we write an algebraic expression, let us say 2x plus 1. So you can take any numeric character for x, but here you are not allowed in Boolean algebra. So in Boolean algebra, you have to take a logical character. So that logical character is represented by either 0 or 1. In the operations applicable to those values and in the properties of those operations, that is the laws they obey, the main feature of this algebra is that it permits only two values or states for its variables. So its Boolean algebra variables has only two states. They are going to be either true or false or on or off in electrical circuits. And for mathematics, if you talk of Boolean algebra, there is always 0 and 1. So let us say you have an equation AB is equal to Y. So if you put A is equal to 1 and B is equal to 1, so what will you have? So in Boolean algebra, A plus B is again is equal to 1. How? So you all know we talk of here in binary language only 0 and 1. So 1 plus 1 is 2, and 2, if you convert 2 into its binary, so that is 1 0. So 1 0 is the binary value of 2. So y is equal to here is nothing but 1 0. Okay, and you cannot say it is as 10. It is, if you talk of Boolean algebra, you always say 1 0. So in ordinary algebra, you simply add 1 plus 1 is equal to 2, where you got y is equal to 2. So here in this Boolean algebra, it is not so. So now, so in this case, we study one gate. We are going to discuss these gates in the later sections. So let's postulate of some theorems of about Boolean algebra. So here we have first theorem, which says what it says: when you add 0 to any, it becomes that when you add 1 to any operator, when you add 1 to any variable, let us say a plus 1 will always be 1, a plus a will always be a, okay, a plus a complement will always be 1. Now here, if you multiply a with 0, it's 0. Multiplication you all know. If you multiply a with 1 will be a. If you multiply a with a, very important one. So these are important stuffs. So in this case and in this case, never forget this. So, and this is also. These are the cases which you have to mark. In this case, a dot a complement is always 0, while in case of addition it is always 1. 0 complement is 1, 1 complement is 0. And if you take the double complement of a, it will be a plus b is equal to b plus a. They are commutative. These are termed for this Boolean algebra. And similarly for the other stuffs, so in which I would like to mark some absorption laws. Okay, associative laws are very simple to understand, but in case of absorption law, you should give your focus to these and these and these. They are important one. So you just have to make them in your memory, these laws, and they will come to you in your exams. So let us take some Boolean functions. So when we talk of Boolean functions, so we talk of OR function. So OR function is basically is A or B. OR stands for plus here. So you take plus sign here. Y is equal to A plus B. And here y is a function of two Boolean variables A and B and is called a OR function, or two variables A and B. So similarly, if you take AND function, that is A dot B, and if you take not function, not means complement, you can say. So you take the complement of the given variable. Now for the NOR function, you take y is equal to not A or B. Similarly, y is equal to here A plus B not, and for the NAND function, y is equal to not A and B is called the NAND function. So NAND function is basically, you can memorize your concept with the formula only. So when you multiply and take the complement, that is called NAND function, and when you take two variables and you take double not of that function, so you called it as identity function. So you just take the double complement, you called identity function. You take the multiplication and take the complement, that is called not function. You take the addition and take the complement, that is called not function. And not function is again single complement. And function is simply multiply the variables, or function is simply add the variables. So now let's discuss them in terms of their electrical circuits. So the NOT gate is also represented by this. Sometimes this NOT gate is represented by this also in some books. So don't confuse yourself. Both have same meaning. So when you put input is 0, your output is 1, not means. And when you put your output 0, your input is 1. Sorry, your input is 0, then your output is 1, and when your input is 1, your output is 0. Here easily depicted. For the OR gate, you all know what do you mean by OR. OR stands for plus. So when 0 plus 0 is what? 0. 0 plus 1 is what? 1. 1 plus 0 is what? 1. And 1 plus 1 is again 1. Okay, 1 plus 1, you said 1 plus 1, what do you say? You say 1 plus 1 is 1, 0. No, 0 is not considered here. 0 will go to carry part. So this is output part, and here you have one carry part also. So 0 will go to the carry part. Okay, so always keep that in your mind. For the AND case, so simply AND case is very simple. 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. So, okay, NAND gate. So I told you NAND gate, when you multiply the inputs and take the complement of their multiplication. So simply what you do when you put 0 0, so 0 and 0 multiply with 0 is 0 and take the complement of 0 is 1, so output is 1. So again you multiply, when you put 0 and 1, so 0 into 1 is 0 and you take the complement of 0, that is 1. Similarly 1 1 1 dot 1, so 1 dot 1 is what? 1. Here 1 dot 1 is 1 and you take the complement of 1, that is 0. So complement is always inverse. Complement means not. Now next, NOR. So what do you mean by NOR? NOR means when you take the input and add the inputs and take the complement. Simply add the inputs and take the complement. So 1 plus 1 is again 1 and take the what? Complement, that is 0. Similarly for the other outputs. So you can do it. Now XOR gate is very important gate, and XNOR gate is also important gate. So you can give your thought or give your concern or attention to this only. A B bar plus A bar B. A B complement plus A complement B is the output. So you just have to put your values A and B and expect the output on the basis of this formula and make this table. So this is an homework for you to complete. Till then, for this video, this is it. Thank you.